Hey guys, Tinman here, and I'm gonna fix an amplifier. So let me give you a bit of backstory on this one. A friend of mine passed me his amplifier so that I could troubleshoot it. Because I'm an electronics technologist, let me take a look at it. You know, I might be able to do something, I might not. I'm gonna quickly check the potentiometers and see if they're crapped out or something, and otherwise I'll just give it back. But I got it, I checked the potentiometers. Actually, no, I didn't. I didn't even check the potentiometers. I would have found something. But anyways, I started probing the circuit with my finger up my nose or something, and I busted something. I made it worse. So originally, it was sounding kind of crappy. I don't even remember what the original problem in the circuit was, but I'm using my old crappy PC-based oscilloscope, just poking around in there, and sure enough, you're gonna see it. But there is a higher voltage side, right, the mains input, and I totally ruined some kind of electrical isolation going on with this through the transformer there, and the two line filter caps exploded, so I got to replace that. Okay, I blew up those caps. I blew up my computer at the same time, and now I gotta fix it. Okay, point is I've had this for a couple months, which is very bad because it's not even mine. And you know what? I saw a recent EEV blog video. Actually, it's not recent. It's an old one. It's EEV blog episode 36, and it's talking about how engineering and fixing stuff is just like a puzzle. And this whole thing is a puzzle, and I didn't give it as much time as I ought to. And you know what? I'm gonna have to take this as a puzzle and stop slacking and stop making excuses, because I want to fix this amplifier, like an amp head for like a guitar, and I want to get this out of my room. I want to give it back to the person because I don't have space in my room. This is like, no. So I'm gonna go through showing you the board. It's pretty interesting because how this company probably does it is that they have designed a whole bunch of boards, you know, like power input boards, DSP boards, front panel boards, front end boards, and you name it. And then all they do is they put these modular pieces probably just together, and they make themselves an amplifier. So you'll see in this amplifier there is a DSP board, a power input board, basically all the stuff I just said. And after looking a bit into the circuit, I found that two potentiometers were dead, most likely. I'm gonna have to desolder those and test them out to make sure that they're dead. And if they are, then perfect, because I did a digi-key order and I got some potentiometers. I got some of those little capacitors that I blew up. I'll replace those and see if I could turn it on again, because this thing doesn't turn on anymore. So fingers crossed. So that is the amplifier. I'm looking at the Spider 2 from line 6. Okay, now this thing I think has, it's like a digital amp head, and it's got some built-in sound effects and stuff, or whatever it is. Like, I'm not an audio guru here, but I know this thing has sound effects in the DSP board. And you know what? It's all taken apart. I hope you did not expect a fully assembled Spider 2, because I actually took it apart before starting this video so that I could figure out, you know, which caps I needed to put in there, which potentiometers. Heck, if I didn't take this apart, I wouldn't have known there's two dead potentiometers on the front panel. So let's start taking a look at these individual components. So we got the mains input, okay, obviously denoted by the massive transformer. This is big transformer, so this thing could probably handle a lot of power. Comes in and goes into your power input, your mains input side here, and you'll see everything's disconnected because I actually took this off, and I want you guys to see this, if I could get the glare out of the way. But can you see that black charring occurring there? Yeah, well, that's where the capacitor exploded. Okay, what happened is there's some kind of isolation going on between here, okay? Because the power comes from mains, goes to this board, goes to the transformer, and goes to the other side of the board. So in this gap in the PCB here, there's no traces going in between, and that's definitely some kind of isolation going on there. And you know what, I totally ruined it, because when I hooked up my PC based oscilloscope, I think I went from one of these pins to that capacitor, and I wasn't even thinking, like, why would I even do that if I don't even know what's there? And boom, that thing just fried. And if I think it might even have fried a bit of the tray, so I'm gonna have to Jimmy MacGyver myself something here. I'm probably gonna have to stick a wire there, scrape off some of the solder mask, and get in there with some solder, because it is not looking pretty. Now it's basically just some preliminary smoothing, I think, or maybe not even. I forget. It just comes in, it just comes in kind of, I think, filters out some of the higher frequency noise, keeps it 60 hertz, goes through the transformer, and goes to the main side, sorry, not the mains side, but the more important side of this power board, where we have these massive caps. There's no regulator on this board, but you'll notice there's a couple inductors. No, actually there aren't. There's two diode bridges, okay, and a whole bunch of massive caps, and they're putting one diode bridge to rectify the DC and another diode bridge to, I don't know, like smooth it out some more, and it goes to the other boards. So in the back, we're looking at line 6 again here, and in the back we've got the main audio amp chips, and this is the main speaker output. So you're hooking these up to your cabinet in the back, or you could alternatively use the wires that go through the bottom, and those are your standard terminals to the female terminals for whatever it is, fork terminal or whatever. So you'll also notice that the filtered or the rectified voltage and power coming from the power board is going here. There's no power or voltage regulator here, and it's just taking whatever voltage is coming in from here. So I don't know the integrity of the voltage source. It's probably pretty good considering they're willing to put their audio through it. So that is the audio amp section of the whole amp. Now the DSP board, you'll see there is power coming through, and the DSP board has a 317. I didn't check for any other regulators, but you know what, this is the core logic. This is where your sound effects are coming from. Like I said, the 317, a whole bunch of caps. I didn't really check what else is there, but you know what, I don't care. And the guitar input is coming right into there. So you could see in the front, I just kind of placed it back in there, but I could pop that out, and there we have it. That is where you hook up your guitar, okay? You could see the little jack, the 1/4 inch TRS jack, and it's very simple. It's a very simple front end. It's using a TLO72. I got a good kick of that because at college we used the TLO72 a bit, and it's a low noise JFET. And it's actually a very nice dual low noise JFET, and you know what? It's funny how they just hook it up to the JFET and send it off to the DSP board. There you go. That is your audio input. And then you know what? I took this part off because that is the front panel. I took that off so I could check the potentiometers. Before, when I got the amp and I was testing it out, I didn't even look at the potentiometers. I said I would, but I couldn't figure it out because I was being a dumbass, and I was being lazy. Finally, I took it off. I checked some potentiometers. I think 2 of them are dead. And that's the story. It mounts through the back here. The 50-pin ribbon cable connects right there. And there's just LEDs and passives. And then it also goes to your headphone output. So you could hook up your headphones here. 1/4 inch TRS, you could put a reducer like a 1/8 inch, and I don't know where people actually use RJ45 for this, but I'm not an audio guru. So the first thing I wanted to change is these 2 potentiometers, okay? And you know what, those caps that I blew up are pretty important too. I'm gonna get to those, but let's start with these pots. I'm suspecting R4 and R9 are no good, because you know what, the same way I probed every single one of these, I got the same response out of all of them except for R4 and R9. And you know what, apart from that, they feel a little grainy, like I'm turning them, and right when I'm scoping it and it says open line or whatever, out of range, I could feel that it's not making connection or something. So I'm gonna desolder these, and we'll get a closer look, because obviously if you're trying to measure resistance and inside the circuit, it's being loaded down possibly by other components. So just to make sure, I'm not going to pop in these really good matches I found. If you take a look at that, those are the potentiometers I got off DigiKey, and they're pretty damn close. Like it's the same pitch between the pins. I don't know about the PC pins that actually grip into the board. Hopefully those will fit too. And apart from that, the shaft is longer, which is no big deal. I could just cut that down with the rotary tool. As you guys know, I love using the rotary tool and hacking shit up. So here's the board, and I desoldered R4 and R9 on this front panel here. You could see it was pretty tough to take out because of these PC pins have a way larger thermal mass than just your normal 100 thou pin. And you know what, I needed some help taking them out, so I got my sister to come over, grab these with a plier from the front as I'm heating them up, and eventually it just came out. I'm gonna have to clean that up before I solder back in some new potentiometers. And I could see there was a bit of damage done, but you know what, it's gonna be okay. I think these PC pins, I'm just using them for a kind of mechanical connection. So here's the potentiometer and the ohm meter, and I am right now at the 0 ohms. Okay, so I'm at the far counterclockwise. Oh, you could kind of see a bit of the resistance there, but you know what? This potentiometer is broken. I'm kind of swiping it back and forth, and here at the far clockwise rotation, which should be the largest resistance value, I'm getting 9.5. That's good. But if I dial it down, it goes up above 10K, which is not supposed to happen, and goes out of range. Maybe there's a resistance on that. So right now it's out of range. Like this is an open connection. This potentiometer is for sure dead. Okay, I'm just playing around with it, changing the ranges, seeing if there's anything popping up, and I get nothing. I get absolutely nothing. And so this is the other potentiometer, and this is the maximum value, 9.7. That's closer to 10. That's still good. I start dialing it down. Okay, working. Oh, it went up to 9 again. Down to 6. And back up to 9 a bit. Down to 4. This is not very linear. Like, this is supposed to be a linear potentiometer, according to the specs. I'm not even at the bottom, and it's reading 0. Oh wait, actually it was. But this potentiometer could be dead as well. So you know, I'm just gonna throw in a new pot, and it's gonna be all good. Wow, look at that! You almost could not tell the difference between the old potentiometers and the new ones. You can't even tell which ones I put in. So the one right here in the center, this black one, that's one of the new potentiometers, and you could see it. Yes, it is a little longer than the other ones, but I could easily just trim that down with my rotary tool. Hey man, I got a little bag of capacitors here. You want to buy some? Okay, so I got some replacement capacitors for the line filter caps right at the mains input. I will show you. This was, oh man, this is tough to hold, but this was one of the ones I blew up. This is actually a good one, but I pulled it off so I could read the specifications on it. So I found something good enough on DigiKey. It's actually exceeding the specs, because it's X1Y2. The voltage exceeds what the other one was. I think this is going to work out, but the hardest part is actually going to be getting these guys onto the board, because as you can see, this ribbon cable here has no connectors on either side, so I can't just pull off one of these sides and have this whole power board come out. Here I could take off this one, no problem. I could just pull this out with my needle nose pliers, and then I'm going to be able to flip it over like so I could get underneath and kind of solder it there. But it's not going to be the best job, because you know what, it'd be so much better if I could just pull this thing out in its entirety. And like I mentioned earlier, you could see the charring occurring on those capacitor pads there. And you know, I'm not sure if the trace is actually blown up right there, and if it is, I'll have to do some remedial work. It might not look great, but it will probably do the job. Just like put in a wire and just slop on some solder. Bam! I quickly soldered up these ceramic capacitors in there, these line filter caps, and you could check out the job I did right there. Sorry about the glare. I don't have studio lights or anything. I soldered it as usual, except for that broken trace. You could see that massive glob there. That is just stranded wire, 20 gauge stranded wire, pre-tinned, wrapped around the leg. I scratched off all the solder mask from the trace so that I could lay the stranded wire on top, and then I soldered it all together. And hopefully that'll be good enough. So I'm going to try turning this on, and I'll put my safety glasses, because if it blows up like it did the first time, I could lose an eye. So let's power her up. Okay, so I just plugged it in the back here. Here goes nothing, guys. Woo! I don't even know if it's working right now, but I'm gonna have to hook up the front panel again so I could see some lights, and we'll find out if it works for good here, okay? So I just quickly put on the front panel. You can see it's half assembled here. I didn't put the knobs or anything back on. I just put two of the hex nuts. And now I'm gonna plug this back in, and we will find out if this works at all. If it does, the lights should show up. If not, I've caused permanent damage to this thing. Here we go. Oh! It works! Yes! Woo! That's engineering. That's engineering. What did I say? Ah! Oh! I actually fixed it. I fixed it. What you get from that is that Tinman can fix the problems he started. Now I gotta fix even more. Ah. So I could actually turn this thing on. It's running right now, but there's still an audio problem, and I don't know what it is. But as soon as I plug the guitar in, all of a sudden I hear this like a super popping sound. Okay, like a ba 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 ba. And it's crazy, and it shows up in both the speaker output and the headphone output, and it's you guys gotta listen to this because it's crazy, okay? When I turn this thing off, I could hear it too. So here we go. You're gonna hear it clip because this is super loud. So that's what shows up when I plug in the guitar. Now I'm gonna show you guys what it sounds like on the headphones, okay? Yeah, you could probably hear that. So this is actually going off right now as we speak. You could hear it right now, and I don't even have the guitar in, so I'm gonna have to see what's the source of this problem. So I'm gonna show you the audio path going on inside this amplifier. I'm gonna show you the different boards, how everything's connected, and I think the first part I have to troubleshoot is the audio coming out of the DSP board or whatever's coming in. So let's take a quick look at that. I did some more troubleshooting right after that. After I kind of went over the board layout, I did a lot of research on the chips on the DSP board, what's going on there. So I have a block diagram to show you guys of the front end before it goes off to the speaker and the headphone outputs. And for the troubleshooting, I got a whole better idea of what's going on. There's some really interesting stuff going on in the DSP board, and I'm gonna love to show you guys this block diagram. It's very simple, and I think there's two chips that are defective, okay? And I'm gonna show you guys what I troubleshooted. I'm not gonna show you guys what I scoped and what I saw in the multimeter, but it should be fairly simple to understand when I talk about it, because honestly I just did some sanity checks. Like I just went in there, you know, is the power supply good? How does the input and output look on this chip? And that's it. So let's get right into it. I'm actually really glad I didn't film the whole troubleshooting that I did, because there was a lot of shitting around and a lot of stuff that I did not have to check. That it was, you know, a waste of time. I'm stuck here at home, you know, no other projects to work on, and sure enough, I'm just going around checking stuff that I shouldn't even be checking. So one of the first things I actually did when I started localizing it to the front end, because this is where the problem is, okay? It's somewhere in the front end, and I'll explain how I got to that conclusion. But I took a look at the DSP board because I think there was a problem there, okay? And it was probably the power supplies, okay? And this is crazy. There's a lot of crazy shit that's going on, and nothing is consistent. The output is inconsistent. Before you could hear the popping on the speaker output, but I can't get that anymore. Like it's when I have it plugged in and I turn it on, I just don't get that clicking anymore. It's really strange, and I don't know why. But when I turn it off, I still get some kind of residual, like just a quick popping in the speaker. It's still consistently showing in the headphones though, so at least I have some way of metering my output, right? So I go around and I scope stuff, and I multimeter some points, and you know, sometimes I hear the clicking sound in the headphones, sometimes I don't. I just have them over to the side over here. So one of the first things I checked for the front end section is the preamp board, which you can't see, but it's really simple. It's just a 1/4 inch input with basically a JFET and a ribbon cable going straight to our DSP board. And so I'm scoping around, and I'm looking, and I see the waveform of the guitar playing, except I don't see the output waveform on the JFET. So I was suspecting the JFET. So I'm probably actually going to replace it and see what happens. But there's something more to this, okay? And it's really strange is when I plug in the guitar into the guitar input, all of a sudden the clicking stops. It's really strange, and it's not even the guitar that's doing it. It's just something, I don't even know what it is. So it could be an inconsistency in this JFET, but when I jack in and there's not even a guitar attached to the 1/4 inch cable, it stops. Like all the clicking stops. And another thing to note is the guitar, like I said, you don't see the output. So when I'm playing and I scope right at the jack, I could see, oh yeah, the guitar, I could see this millivolt signal coming in, but I don't see it going to the DSP board. Before I move on, I have to show you guys the block diagram I came up with, because or else I'll be naming chips and you guys won't know what they do, how they're implemented in the grand scheme of things. So this is basically the front end of the DSP board. This is the block diagram I came up with. This is the DSP chip, okay? It's some Motorola chip, DSP something. I don't care, because if this is no good, then I can't fix the amp, I believe. But anyways, at the top over here, I put our input, okay? Now your guitar comes into here. We have the preamp, which is the TLO 72 dual JFET, low noise, 3 megahertz bandwidth. And anyways, like I said, I could see the input coming into this JFET, but I don't see the output, and I don't see it going to the board, right? Now, it reaches the board, or if it were working, it would go to the board, and there's this special chip, okay? This is how we do the audio processing with this DSP chip. This DSP chip is actually interfacing with a separate audio codec chip, okay? The AK4528VF is the audio codec chip, and what it does, it takes an analog, and it like an analog guitar signal, and it turns it into a digital stream or whatever it is. We got some kind of communication protocol going in between here. It's similar to SPI, except it isn't. And anyway, so you've got it coming in, and the DSP board just reads it in as it wants it, and whenever the DSP does some of its processing, it sends it back to this audio codec chip, and it goes on for further processing, and finally the output to the speaker and the headphones. And then apart from that, so yeah, this is like the interesting part of the circuit. I really like this whole idea of having this audio codec chip. It's got like a 96 kilohertz bandwidth, 24-bit sampling. It's I don't know, it seems like a pretty awesome chip. It's $5. Expensive though. And for the front panel, I drew this. It's not really standard, okay? But here I'm showing a bunch of potentiometers. I put 2 potentiometers, and then I put dotted line in between just to show that there's multiple. And that goes to an A to D chip, okay? This DSP chip is literally just a processor. All it's doing is it's taking in digital information. Like, it's not really doing anything analog. It's just taking digital, processing it, and doing something else with it, like outputting it back to this audio codec chip. But it's like this DSP chip isn't even doing any A to D. It's taking a separate chip for that. So the TLC 542C is an A to D chip. I think it's like 8 channel, or no, it's 11 channels of A to D, and I think it's 8 bits of quantization. And so you've got your potentiometers coming in, and sure enough, you got some kind of digital interface back to the DSP board. For the LEDs, you've got the DSP board talking to a buffer, which is the HCT 541. It's an octal buffer, so it's got 8 outputs, tri-state, right? So you've got high, low, and high impedance. And the way that we're actually illuminating all the LEDs is with an LED matrix, because if you've noticed, we have more than 8 LEDs. I'm counting them right now. 1, 2, 3, 4, 5, 6, 7, 8. We have like 11 or 12 LEDs, and the only way to do that with 8 outputs is to have an LED matrix. So that's how the DSP board does it. I don't care too much about how the LED matrix is, topographically laid out, but yeah, I understand that it's LED matrix. So I mentioned how the output is not coming out of the preamp. Well, now I got some crazy shit happening after this audio codec chip, okay? I think what happens is that it goes to a TLO84. It's another JFET chip, except it's got 4 JFETs, low noise, 3 megahertz, similar to the TLO72, except it's a TLO84. And I'm guessing this audio codec chip puts out a weak signal, right? So it amplifies it. And then there's another 2 chips, like 2 stereo amplifier chips that bump it up even more. And I think that's where it goes off to the speaker and the headphones. So now let's take a look at the board, okay? And then I'll show you guys some of the output I hear. It gets pretty fun, okay? A lot of my useless checks, which weren't actually completely useless, was checking power supplies. So I checked the chips. There's 3 linear voltage regulators. I think this one is this one's the 5 volts. This one's the 3.3 volts using a LM317. And the last one on this side is, I think, a 9 volt or a 12 volt regulator, okay? I checked the inputs and the outputs of multiple chips. So that would include the AK 4528VF, the audio codec chip, which is right here. I checked the input. There's nothing coming from the JFET, right, as I have mentioned. So there is no output, and I confirmed that with the scope. And that goes to the DSP board. I didn't scope anything at the DSP board. There's such a fine pin pitch. I didn't want to scope anything and accidentally short it and bust this chip, because I don't want to dish out 20 bucks. Or heck, I can't even dish out 20 bucks to buy this chip, because I wouldn't be able to program it correctly, right? I took a quick look at the A to D chips and kind of confirmed that it's for the potentiometers. I quickly looked at the output interface with the DSP chip, and same thing with the octal buffers. One of the things I noticed is actually there's some kind of output at the AK4528 chip, the audio codec chip. There's like a little dip. You just see it go and bloop, bloop, and it's a 10 hertz little dip, okay? This 10 hertz is only occurring when you could hear the 10 hertz clicking in the output. And I don't know if it's actually coming out of the audio codec chip, or if it's just some kind of like residual feedback coming from the more downstream chip, which is the TLO84, or the stereo amplifier chips, which are back here, and you probably can't see them. But I could see some kind of dipping occurring here. This chip would be no problem to rework as well, because it does cost $5, so it would be a pain in the ass to actually buy it. But I could replace this if necessary. Now I'm going to show you guys something crazy, okay? I'm literally going to turn this on, and I'm going to blow in this area on the voltage regulators, because I'm thinking, what if these are getting too hot, okay? Because power supply is just such a common room for error, right? I'm gonna see if these guys are overheating. So listen to that. That is normal operation of this device. That's the 10 hertz clicking coming from the headphones, okay? Now listen to it as I start blowing on the voltage regulators. It stops. And it slowly speeds up again. I don't know if you could hear that, but it used to be like 10 hertz, slowed down back to 0, and now it's picking up after I stopped blowing on the linear voltage regulators. Okay, truth is, it's not the linear voltage regulators, it's the TLO84 chip, okay? It was really weird though. Before I could consistently like just blow on these regulators and it would slowly decrease the frequency of the clicking, except this time it didn't actually do that. I don't know why. But I started blowing a little more on this chip, and it seems that basically this chip is actually what's wrong, because it's not heat, because I've tried turning it on and listening to the output and just grabbing one by one, grabbing these regulators to cool them off, because they're running pretty hot, okay? So my body temperature is lower than the temperature of these regulators. If I touch them, it'll cool it down, and hopefully I could determine which one of these regulators needs to be changed. But it wasn't that. None of that. This was working. I would touch it, cool it down, no difference. Touch it, cool it down, no difference. Same thing for this last one. I touched it, cooled it down, and there's no difference. Okay, that's weird. So finally I start touching all the chips, one by one. Oh, the TLO84, as soon as I touched it, the clicking stops. Magic. What kind of ghost is that in the machine? So, I'm suspecting there's something wrong with this chip, and like I look at the output, I touch it, then the output is gone, you know, it's hopeless. I'm gonna change this chip essentially. So part of the reason that this took me a week longer than expected is because I had to order in some parts, okay? I've got myself the JFETs, the front end JFETs, the TLO72s, and the TLO84s, okay? So I'm going to start replacing these chips, and I also got something every electronics technologist or hobbyist or engineer should have, is some chip quick, okay? I've never actually used chip quick, but I have needed it a lot in the past, okay? I have been able to desolder QFP packages without chip quick, but with this stuff, it's going to be so much easier. I plugged it in. I'm ready to test this out, so you guys aren't going to hear it because it's only in the headphones, but I'm going to bring it up. If it sounds good, I'm going to bring it up. If it sounds bad, I'm going to bring it up to the microphone. Here goes nothing. Nope. It's definitely worse. Definitely worse. And it's not going away either. That is quite disappointing actually, but hey, that's the nature of troubleshooting. I mean, it might be some kind of contamination, or you know what? It wouldn't surprise me if one of the capacitors on here is actually bad, because that could explain, you know, some kind of leakage or some faulty filtering could really explain this kind of behavior. So, I mean, I might troubleshoot this further. I might show you guys in the future if I could fix this thing, or I might just chuck it. I don't know. Yeah, that's it. If you guys enjoyed this episode, give it a thumbs up, subscribe. I know I didn't actually troubleshoot the whole thing, but you know, maybe in future videos I will. I have a website, www.tinmanelectronics.com, or you could follow me on Twitter at JustinTinman. So that's all the time I got for today. Sorry, guys. I mean, it's getting close to Christmas. I've got a Christmas function with the family. That's all I can do. I'm a little I'm more disappointed than you. I know this is quite the turnout. There's got to be leakage somewhere. It's got to be a cap. It's got to be a cap. And I can't tell which one. Like, I'm looking at the board and I can't tell which one it is.